A sequence of 6 designed to monitor the planet and to help better understand our climate, our environment, and our future potential. Tonight, we'll be bringing you the live transmission of the launch, as well as background information about the satellite and its mission. We also have a number of people joining us on stage, from scientists and engineers to future users of the data as well. First of all, I would like to talk to Volker Liebig, ESA's Director of Earth Observation Programs, who's kind of the driving force behind this program, along with the European Commission. Mr. Liebig, hello. I will shake your hand. Now, we've seen the roll call by Pier Paolo Emanuele, and we know that there's a new satellite waiting to be launched. Can you briefly tell us the purpose of Sentinel-3?
Yes, you know, Copernicus, this is what we have done 35 years ago with meteorology. We wanted to have an operational observing system, but this time for environment and civil security. And Sentinel-3 is an element which gives us a daily state of our planet. So we will cover the whole planet in one day with a focus on the ocean. We have seen the video. So we have an El Nino year. So El Nino we can see with this satellite. We will see pollution, but we can also see other things. We will feed numerical sea forecast system, similar to the numerical weather forecast, which will help ship routes. But also on land, we had already satellites monitoring the vegetation. This satellite will do that now for decades. And we will also see the change of the land cover, the land use of this planet. All these are parameters which are very important in the context of climate change.
Well, thank you. We'll be going into a lot more detail about all of that later on, but for now, I'll let you take a seat again. Thank you, Volker Liebig. Now, of course, while we're waiting for the first live images from the launch site, I'd like to speak to Matthias Muck, who's here with us. He's the mission manager at the launch service provider Rockot. Thank you very much for joining us.
Thank you for inviting me.
Now, we're going to talk about the launch campaign. This is what's being done on site during the last few weeks. And now the team has had a very long journey, haven't they, from actually getting off and getting the satellite to Plesetsk. Can you tell us actually where in Russia is Plesetsk?
Plesetsk is located about 800 kilometers in the north of Moscow. So it's in the Russian Tiger region, about 200 kilometers south of Arhangelsk. So it's located at 63 degrees latitude, which makes Plesetsk Cosmodrome an ideal place to launch a spacecraft into polar orbit or near polar orbit as Sentinel-3.
Okay, great. And we're starting to see some images up there. Maybe you can see them on this screen. Can you explain to us what exactly happened in the time when the shipping of the satellite got there to actually today, the launch?
Yeah, I mean, the launch campaign starts with the shipping of the spacecraft. That is already a little bit later into the campaign. That is start of the joint operations where the spacecraft and the launcher are brought together. So here we see mating of the spacecraft on the adapter system, which at this moment is being hoisted on the upper stage that we see coming close by in this video. Here, the spacecraft is already mounted on the upper stage, and the payload fairing is brought onto the upper stage, and the spacecraft is encapsulated for liftoff under the fairing.
Gives you an idea of the scale of it as well when you see these pictures and the people working next to it.
Well, although it's only a small rocket, but it already has quite some dimensions.
Yes.
Yeah. So here we see the insignia being placed on the payload fairing, and we see that everybody is signing the payload fairing, giving good wishes for a good and successful ride to orbit. What we can see here is the rollout, the so-called rollout of the upper composite to the launch pad. The upper composite is protected against the fairly cold winter. We take all measures to protect your spacecraft, even on the way out to the pad. Here it's arriving.
Some fantastic images.
Well, we have to remember Plesetsk Cosmodrome is a military launch site, so the Space Forces are actually the operators of the launch.
And that gives you some idea of how cold it is there as well. Everybody looking very wrapped up and lots of snow behind.
Yeah, that was 4 days ago, and here we see the hoisting of the upper composite into the launch tower. The lower part of the rocket is already standing there, the so-called booster part, and we do here a vertical integration, and once that is done, we close the door of the service towers, and that protects the spacecraft for a couple of days against the cold temperatures and to keep it
Fantastic. Well, thank you very much, Matthias. You're going to be talking to us later on during the launch. But right now, we're going to go back to Mrs. Baer in Berlin. The connection dropped with her just earlier, but she's back with us now and would like to say a few more words about the launch. Mrs. Baer, are you there?
Yes, I'm still there.
Hello, thank you for coming back to us. So, would you like to add something more to what you were saying before?
No, actually, I was supposed to hold a speech, you know.
Okay, please continue.
Yes, so thank you very much. So Mr. Dancing, Mr. Ratier, Mr. Liebing, ladies and gentlemen, we can be proud of the fact that this European Community project has been operational for nearly 2 years now and bears witness to the excellent European cooperation, featuring a clear division of responsibilities between the European Union, the ESA and the member states. So everyone asks, what can Copernicus do? So Copernicus is a mission of many talents, and thanks to Copernicus, we will be able to do many things better than we are now, and we will learn a lot. So whether that be on climate and weather forecasts, disaster and crisis management, or on the protection of maritime transport routes, the availability of data on the state of our planet is of great importance to the federal government. So therefore, Germany, that is my ministry, makes a significant contribution to the funding of the Copernicus space component. The application of remote sensing unlocks an enormous potential that we have to tap into. Earth observation plays an important role for key tasks of our ministry, the Ministry of Transport and Digital Infrastructure, especially in the field of meteorology and increasingly for the safety and maintenance of land-based airborne and waterborne transport infrastructure. So speaking of Sentinel-3A, water is just the right keyword. After the successful launch of Sentinel-1A and Sentinel-2A in the last 2 years, the Sentinel-3A observations will now enable us to particularly plunge into the oceans. This mission is equipped with state-of-the-art instruments that will permit us to provide more accurate data for the ocean forecast. I would also like to mention the European Organization for the Exploitation of Meteorological Satellites. So for me, as a Franconian woman, it's easier to call it EUMETSAT. So alongside ESA, this Darmstadt-based intergovernmental organization is also an important player in building the space component Copernicus. For example, the operation of the Sentinel-3A instruments will be handled by EUMETSAT. EUMETSAT will also provide the products for the marine applications. Sentinel-3A was designed particularly for marine applications. The satellite will collect data on the state of the sea, changes to the sea level and the pollution of the seas, the temperature of the ocean's surface, as well as ice extent and ice thickness. Information on extent and thickness of ice masses are one of the utmost importance for shipping traffic. What I mean to say is the following. With this Copernicus satellite, we can make shipping safer. So ladies and gentlemen, our ministry is also aware of the responsibility to ensure that Copernicus data will be used at national level. Users from public authorities and from the fields of industry and science are to derive optimum benefit from the Copernicus data. Against this backdrop, the BMBI funds the National Copernicus Integration Measure, which makes it possible for projects and authorities to establish Copernicus data in their administrative processes. A further element is a national Copernicus IT infrastructure, which provides for easier access to Copernicus data and services. The pilot phase is to start this year, and we have already received very positive feedback from the user community on the excellent data from Sentinel-1A and Sentinel-2A. ESA statistics show that the data is met with great interest. I expect that Sentinel 3A will increase the demand for data many times over. And on this note, I hope that after a few nail-biting minutes, we will be able to breathe a sigh of relief. So thank you very much to give me a second chance to talk to you. And now I'm as excited as all of you are and keeping our fingers crossed. All the best.
Thank you very much. I'm glad we got to hear from you again properly. That was Ms. Dorothea Bär there from the German Federal Ministry of Transport and Digital Infrastructure in Berlin. And now we're going to head over to the location and there at the liftoff is Guido Levrini, ESA's Copernicus Space Segment Manager, or as he likes to be known, ESA's Mr. Sentinel. So Guido, are you there? How cold is it at the launch site in Plesetsk?
Good afternoon to all the friends and colleagues at ESA and the other ESA centers. Here the temperature is -4. We have a little bit of wind. There was snow until 1 hour ago, but this is not a problem for the launch. I can report, I'm happy to report that the weather is green despite the snow. The rocket is green. The satellite is green, and Bruno Berruti, the project manager, has a few minutes ago given the satellite-ready status. So in short, we are all set to go. We are green to go.
Well, that is great news. Thank you very much, Guido Levrini. We'll be coming back to you later on this evening. Now, ladies and gentlemen, whilst the rocket is launched from the control room in Russia, of course, the satellite is controlled from here in Darmstadt at ESA's Space Operations Center. Inside the main control room is Andrea Accomazzo, the Deputy Flight Director. He's on alternating shifts with Pier Paolo Emanuele, whom we saw earlier. Thank you, Andrea, for being with us. What's the actual status of the launch there, please?
Thank you, Luis. We are now in the final part of the countdown procedure here. There are people in Russia that have been preparing the spacecraft for the last 10 hours, more than 10 hours. And on our side, we have been preparing the ground segment. We have several stations supporting us throughout the world. We have 3 stations close to the North Pole, in Norway, in Svalbard actually, in Sweden, and in Alaska, another station in Antarctica. We have been checking our links to these ground stations. We're ready to receive telemetry. We're ready to send telecommands. And the team has been focusing on this part in the last hours. Now we're approaching the final minutes before launch. Spacecraft will be switched to internal power, so we rely purely on its own batteries till the solar array deployment after separation. This is a big task for the spacecraft itself, and we are ready to go on our side.
Well, that is good news. We can see lots of people there eagerly waiting for their work to proceed later on this evening. Can you introduce us to a few of them, perhaps, please?
Yeah, sure. We are ourselves here in the main control room with the core of the mission control team is. On the front door here on my right side is you can see the engineer expert in operating the various subsystems of the spacecraft, the OCS, the data handling subsystem. We have the spacecraft operation manager sitting in the middle of this front row, is the focal point for all what concern spacecraft operations, spacecraft activities. And on my left side, we have seen here the flight director. We have already seen Pier Paolo earlier on going through all the checks we do before launch, giving our readiness to go for launch. And here in front of me right now, we have the positions dealing with all the ground segment status. So ground stations, all the antennas which are supporting us, we are monitoring, overseeing their operations. We also have the colleagues dealing with all the software systems that we use to talk to the spacecraft, and they are also checking that everything is green for launch.
Brilliant. Thank you very much for showing us around there. We'll be talking to you again later on this evening. Now, before we continue, let's just have a quick look at the clock, shall we, and see how close we are to the launch. Is there a clock available? There we are. We can see it there. Still some time to go, so we're going to continue now. 35 minutes there on the clock. So let's have a brief overview of the mission and talk about it in a little bit more detail. As you can see, we have a number of people here on the stage joining us for this discussion. First of all, I'd like to introduce Pascal Autre-Gérard, the head of Earth observations at the French space agency CNES. We also have Mauro Facchini here, the head of the Copernicus unit at the European Commission DG for Internal Market, Industry, Entrepreneurship and SMEs. Alain Ratier is joining us as well, the Director General of EUMETSAT. Donato Amoroso, Deputy CEO of Thales Alenia Space, and Volker Liebig as well, ESA's Director of Earth Observation Programs, whom you saw before. Thank you very much to all of you. Welcome to the stage. Now, Mr. Liebig, you summarized the mission before, but now let's go into a little bit more detail. Sentinel-3 is the next major step following the previous scientific Earth observation services provided by ERS, Envisat, Landsat and others. So what is the major difference of this one to the other satellites?
Well, the satellites you mentioned, ERS 1, 2 and Envisat, European satellites, and Landsat, an American satellite system. So concerning our European satellites, it was all scientific satellites. So it was one-offs or two-offs as CRS. Nevertheless, they gave us already an archive of 20 years of continuous measurements of our planet. The real step forward in Copernicus is that we have an operational system. I mentioned before what we have done in metrology 35 years ago. We have Alain Ratier here from EUMETSAT. So this is exactly the difference. We are now creating a system which will last forever, and with what we have already, let's say, contracted and the budgets available, we are already sure that we can maintain everything far into the 2030s, depending a bit on each satellite's lifetime, which gives the users also the assurance that they build their own applications on it. And this is really a major step forward.
And this is a program that is jointly commissioned by ESA and the European Commission. Why is Europe so committed to Earth observation from space?
Probably it starts with the fact that Europe is very committed to the environment. Europe has always led the environmental movement on the citizen level, but also political level. The European Union, also the Commission have driven this file. In the climate conference we have seen in Paris, thanks to the French diplomacy, was successful. And we have now an agreement worldwide, and Europe has now to contribute to that. And one of the contributions we wanted always to have is our own eyes in space. We were for 35 years in certain areas really dependent on Landsat, for example. A fantastic system, now a bit, should not say this, a bit outdated maybe, because Copernicus delivers much better data. And this is also the reason why the US has started to use our data. So we have now our own eyes in the space, but we offer this to everybody because the data are open and free, so that all nations of this planet, also following the COP21, can use the data to make their own reports and assess their environment in their countries.
Well, maybe we can ask Mr. Facchini what your views are on why the Commission has such a big interest in the system.
First of all, when we speak about Copernicus, it's really the European Union Earth Observation Program. So we are very proud of that. And as you say, maybe someone might ask why. Actually, because it's for the citizens, it's for the policies, EU policies. So this is the reason why we are working in this. We are very proud to have been working with the member states, with ESA, EUMETSAT and other entities, and to make it. So to make something that is useful, as I said, citizens, policymakers, but also industry that can make out businesses out of what we are generating. So again, we are proud of that, and we hope that today will be another success.
And have you been pleased with the launches so far of Sentinel-1A and 2A?
We are very pleased with that, and this is also demonstrated by the high level of downloads of data that are generated. ESA is giving us updated on what's going on. Today we spoke mostly about marine applications. It's true that we look about the oceans, but also about the lands, for example, about deforestation, all crops, or food security. This is also very important in our world today.
Well, of course, alongside the European Commission, the European and national space agencies all provide their expertise to Copernicus. One of them is CNES, the French space agency. Pascal, France must have a long-term record with oceanography from space.
Yes, it has started, in fact, more than 25 years ago with the launch of Topex's Poseidon mission. So as it was said by Volker, at that time it was research mission. And then we have had JASON 1, JASON 2, JASON 3, and the next one will be JASON CS Sentinel 6. So which is mean that now we are no more in a research domain, but really in operational domain. So it's really, for us, it's really a success to have seen this series of satellites getting more and more operational, more and more used by operational user, meteorology people, and also oceanographer and so on. So it's really a great success to see this evolution.
Well, EUMETSAT has also come on board for this Sentinel-3 as well as part of the Copernicus program, and it's been delegated to operate the marine component of the mission. What does that mean, and what will EUMETSAT's role be within this satellite mission?
First, it means what Jan Werner has explained. We have a Europe team, and it's here. And EUMETSAT is very proud of being part of this team. And as the others, as ESA, we had to be ready for tonight as well. And it was a challenge. But now we look forward for the launch. And 5 months from now, we expect to take over operations of the spacecraft from ESOC and start to deliver products, marine products. As you say, we are responsible for the marine mission. And for us, it's a new commitment, and a new commitment to a new customer, the EU, and this closes the loops. And as you know, we are also involved in JASON 3, so we hope to deliver an integrated data stream for marine products from JASON 3, Sentinel 3A, and also our own missions.
Okay, and because we are about to launch Sentinel-3A, Thales Alenia Spaces just a few days ago signed the contract for Sentinel-3, C and D. Mr. Amoroso, it seems that you're quite deeply involved with the Copernicus program as well.
Yes, indeed, quite deeply. Thales Alenia Space started this journey a long time ago. Actually, we were working on the Copernicus when it was named GMES at the time. So we've been developing all along this journey our competence in this team, and we are very proud of it. As a prime contractor, we felt the responsibility being responsible for designing, development, integrating, and testing the satellite. So which means that with our competence, we try to put all together around a satellite. So a long journey, 8 years, developing in Cannes, in our plant in Cannes. And with the contribution also, because rather than the satellite, we are also contributing with main 2 instruments in these missions. One is an optical and the other one is altimeter, and plenty of technical details during the day today will be plenty of that. So we felt very proud, and also our Rome facility, we provide the platform on that. So quite deeply involved, thanking the trust that European community, ESA, CNES, all this, we felt like a partners, and we felt the responsibility of completing this.
Okay, thank you very much. Well, the final question then just goes to Mr. Liebig, and just very quickly, 2016 seems to be the year of Copernicus. You've got 4 satellites being launched into orbit, so is the program on track?
Well, I would say it's on track. We have already quite some way behind us, together with the Commission, together with EUMETSAT, together with our member states. In fact, it started in '98 with the famous Baveno manifesto. I was myself part of this group who drafted that. I was not thinking at this time to sit here tonight to look forward to the 3rd satellite. But we have still this satellite today and another 4 satellites to launch for the first wave, let's say, in the next 20 months. I can only cross my fingers. So far everything works, the ground segment works, the satellites work. We are looking forward, we are all ready. We have invested a lot of time and effort and generosity, European also engineering art. So I think, yes, we are on track.
Great, good news. Well, thank you very much to all of you for being here with me this evening. Now, of course, let's have a quick look once again at the roll call, the time, sorry, I do apologize, the clock. Let's see how soon that launch is going to be happening. Oh, there you are. It's ticking away very quickly, just 15 minutes to go. So now we're going to be joined by Detlef Stammer. He is the Professor of Oceanography at the University of Hamburg Center for Earth Science Systems and Sustainability. Mr. Stammer, thank you for joining me. After a century of scientific observations on the high seas and a few decades of satellite observation, what do we know about the oceans today?
Oh, we actually know quite a bit about the ocean today. Basically, we have established its role, its circulation, its large circulation elements, its transport properties like heat and others. We have seen this, that the ocean is in fact home of an incredible ecosystem. It is the medium for transportation, for traffic, for food supply. But we actually have in particular established the ocean's role in climate. We basically know that the ocean stores most of the heat in the climate in the Earth system. We basically know it stores most of the available water. It's an incredible important part for the carbon cycle and so stores also carbon. And so we basically have established now that the ocean is in fact a very important element of the climate system.
Okay, and there's still a number of questions that remain unanswered. What key issues are on the top of the ocean research agenda?
Well, first of all, we should not forget that the ocean, in fact, is historically undersampled. So we know a lot, but we also haven't seen all. And so having instruments and satellites providing now the information, the data that we can use to investigate all that we don't know is very important. And the biggest issues right now are two, basically. One is the ocean's role in the changing climate system. So if it comes to changes in the climate system, how much of that is triggered or in fact caused by the ocean? How is the ocean responding itself to changes in the Earth's climate system? That's really what we need to understand.
And the second one?
And the second one is in fact sort of the health of the ocean. We know it sort of keeps the ecosystems. It is a lot of importance for our food, and we really need to monitor that, how that health of the ocean is changing. We all know about microplastics, we know about pollutions, and that's the other thing we really need to monitor, how the health of the ocean is changing over the years.
Okay. Thank you very much for explaining that to us. Now let's check with ESA's Sentinel-3 emissions scientist, Craig Donlon, if these topics Mr. Stammer mentioned will be addressed by the new satellite. Craig is here with me, along with two other people, which will come to you very shortly. The microphone is just on the chair there, if you don't mind passing it over. Thank you very much. So Craig, can you tell us, does Sentinel-3 cover these issues that I've just been discussing with Mr. Stammer?
Yes, it does. Our powerful... Sorry, all there. Yes, it does. Our powerful radar altimeter, together with the microwave radiometer, will be able to measure the height of the sea surface to an accuracy of about 2 centimeters from 815 kilometers up in space. We also have a thermal infrared radiometer, which will measure the temperature of the Earth, the sea and land surface temperature radiometer. And that can measure the temperature of the ocean surface to an accuracy of about 0.2 degrees Celsius. You try measuring the temperature of your bathwater to that accuracy. And this is complemented by our ocean and land color instrument. And this is a fantastic instrument with 21 spectral bands, which measures in visible and near infrared, providing data of a very high quality and precision.
That is very, very precise, actually, indeed, isn't it? So that's great news. And providing data is predicting the weather, and this is, of course, the speciality of EUMETSAT. And we also have Mr. François Montagnier with us, the Marine Applications Manager at EUMETSAT. François, how will oceanography profit from Sentinel-3 data?
Well, as you just said, the marine forecasters will be able to use the Sentinel-3 data in the same way as our weather forecasters have been using the weather satellite data. One of the strengths and interests for them of Sentinel-3 is that the three instruments on it are very complementary and give insights into a three-dimensional representation of the ocean. Just to give you an example, combining the sea level information and the sea surface temperature information actually allows to estimate the total amount of heat in the ocean from the surface, which is seen directly, down to the very bottom. Another example is the ocean color imager, the OLCI, which will see plankton, and that is life and water quality, not just at the surface, but also in the first tens of meters where most of the life actually happens. And the structures which we see, the gyres, the eddies and streams, which we see on plankton images, they relate directly to circulation, which in turn is explained by the altimeter measurements.
Okay, thank you very much. Now, just about 2 weeks ago, Pascal actually already explained to us that the French Jason 3 satellite was launched into orbit. This is another satellite with an altimeter on board. Philippe Escudier from the French space agency CNES is the program manager for oceanography. Philippe, why do different satellites do the same job?
This is just because a big advantage of satellite, its ability to make a global coverage of our planet. However, one satellite cannot be in every place at the same time. So we need some time to get this global coverage, and this depends on the characteristic of the instruments. And if we consider the Sentinel-3 satellite, we have the optical payload, which has a wide field of view, which allows to meet this requirement that Volker mentioned of a daily coverage of the planet. For the altimetry mission, we use a narrow beam radar. So in this framework, we cannot meet this requirement with just one satellite. Actually, we need 3 satellites to be able to monitor the eddies that will be then analyzed and forecasted by the operational users. So we need simultaneously 3 satellites. In the future, this will be done combining Sentinel-3A with Sentinel-3B and later on by Sentinel-6. And now, we will be able to do the job combining Sentinel-3A with Jason 3, which was launched a few weeks ago, and with Sarawal-Tikara, which is another cooperation between France and India, and which is still in orbit and which has taken the following to Envisat. So combining these 3 satellites, we will do the job for the users.
Thank you for filling us in with that. One final question then just to Craig. You say that today's science creates tomorrow's applications. So what is your vision about the applications that will come from Sentinel-3?
Well, I think for Sentinel-3, it's great applications underpinned by great science, together with great research and the operations that we have. And this will allow us to get the best out of Sentinel-3. And why is that important? Well, that's important because we need to understand how the policies and decisions made at the European level impact not only us as citizens, but also how those policies impact other regions and other places in the world. And for me, that's the big picture of Copernicus. It's all of these things together, working in harmony and getting the best out of what we've got.
Nicely said. Thank you very much to all of you for being here with us on the stage. Now, ladies and gentlemen, we're in the final 10 minutes before liftoff, and I'd like to welcome Paolo Ferri, the head of the operations department at ESA in Darmstadt. Paolo, this is your first launch of 2016, but it seems that it's a busy year for operations.
Yes, in fact, it's going to be perhaps a record launch for ESA, a record year for ESA, for 16 launches planned, 16 satellites in flight and 6 launches planned for the whole year. So this is really a lot of work for us.
Well, it's a pleasure to mention at this point as well that the Operations Centre will be celebrating their 50th anniversary next year. Paolo Ferri, thank you very much. And from this insight into the Operations Centre, we're going to go back to the launch site in Plesetsk. Mr. Sentinel, Guido Lavrini, is there once again for us, and he should have the latest information about the status of the launch. Guido, are you there? How's everything looking?
Yes, everything is proceeding nominally. I'm not sure if you can see the image, but the tower is moving away from the launcher. The automatic test sequence has, launch sequence has started, and the satellite is now, I see that you should get the images now.
Yes, we have them.
And the satellite is on its batteries since a few minutes. It will be surviving on its own batteries for another couple of hours.
How close are you actually to the
moment
launch site?
Yes, yes. And this is the moment, Louise, if you allow me to thank all the teams in partners, organization and industry who work on this project for these long years. And in particular, I would like to send a special thanks to their families who have supported them all along this long way. And from Plzesk, we are green and go Sentinel 3A.
Well, that's fantastic. I know it's your job to be there, but nevertheless, you look pretty excited.
We are, with the enthusiasm that there is around in Plzesk, you can lift the rocket and place the satellite in the right orbit.
Well, thank you very much for that, Guido Livrini, live from Plzesk Cosmodrome. We've all got our fingers crossed here as we enter into the final few minutes before the official countdown begins. Whilst we see the live images continue from the launcher standing on its launch pad, I'm assisted again by Eurocot's mission manager, Matthias Muck, who knows all the details about the launch, I'm pleased to say. Matthias, now there are just 5 minutes to go, and we are starting to see the images again in a minute of the Rockot on its launch pad. The launch service tower has just been retracted, as Guido just told us, and we can see the rocket there standing in a tube. Now, can you explain what that is?
Yeah, that is actually a very particular feature of the Rockot launch vehicle. To understand this, one has to know that the Rockot launch vehicle is actually derived from an intercontinental ballistic missile, the SS-19. And we have seen earlier in the video when the upper composite was lifted into the tower that there was already a part standing inside the launch tower, and that is actually the part that is inherited from the SS-19. So the SS-19 as a weapon system was constructed in such a way that it could be launched out of a container in which it could be transported basically anywhere, and for strategic reasons then launched out of that container. So the Rockot is basically adapting this launch mechanism in order to change the design of these two stages, and we basically put on top the upper stage that carries the satellite, and that makes the Rockot. That's why we see the launch vehicle only sitting in the container, and the first time that we actually see Rockot completely is when it lifts off out of the container.
Let's have a little look quickly at the clock and see where we're at now. Just under 3 minutes to go. Now, if we look at that Rockot, you said already that it was a small rocket, but how large actually is it?
It's almost 30 meters high, a bit more than 29 meters, and it weighs 107 tons. So, yeah, that is small for a launch vehicle, but still quite impressive when you stand next to it at the pad.
Yes, I'm sure. Now, we are, of course, in the crucial few minutes, but over the last few hours, there's been a lot of activities going on. Can you talk us through what's been happening?
You just showed the countdown, which showed that we have passed the 3 minutes barrier, and that is what we call the transition into the irreversible sequence. That sequence basically means that now we're committed to launch because the automated sequence that has been started about half an hour ago has now triggered activities on board of the launcher that cannot easily be redone. So, for example, it's the pressurization of the fuel tanks, it's the opening of the fuel tanks at some point, and that is the point when you basically, when you can't actually turn back and when you need to launch.
So only 2 minutes to go, and the final sequence is just starting. But are we going to hear this countdown in Russian, do you think?
I'm afraid that we only see the pictures. I hope we see a countdown somewhere from the control room. But I think there's an important point to mention. We saw the countdown, and if I'm not mistaken, the countdown is actually counting down to a reference time that we called end of gyro setting time. That is not the actual liftoff time. So you need to be prepared that another 14 seconds, nothing is happening. Well, after 11 seconds, you will see the ignition of the engine. That is absolutely normal.
We must go over to there now, actually. So let's watch and listen to the launch of ESA's Sentinel 3A from the Plzesk Cosmodrome, and we will talk to you again after the liftoff. and gentlemen, Sentinel 3A has lifted off into space, and I'm sure you'll agree that was a very impressive flight. Now, of course, we're entering into an exciting early phase of the flight, which is going to be shown here on our screens. And we're going to be starting to see some of the telemetry come through. So do you want to talk us through what we're seeing here, Matthias?
Yeah, we have seen the liftoff and basically the quick disappearance of the launcher into the night sky, which is related to this, well, very high thrust power that the rocket has. It has twice the thrust to lift, twice the thrust that is needed to actually lift the rocket. And now we see here already the first flight takes about 2 minutes, and the first stage flight takes about 2 minutes, and then the first stage separation takes place. So that is actually what we see in this animation, and what we see as well is basically all the maneuvers that the rocket is performing during ascent in an animated version.
Okay, and so of course we are now 3 minutes into the flight of the Rockot. How does the data of its position come down from the rocket to us here?
We are actually using telemetry that is downlinked from the launcher to Russian ground stations. Just a remark, that is the indication that at that time we're expecting payload fairing jettisoning. That is taking place at about 120 kilometers of altitude once we have left the atmosphere. So coming back to your earlier question, the telemetry is basically downlinked to Russian ground stations that are located on Russian territory. That is also a reason why we're later on losing visibility. That is absolutely normal, and that only indicates that we are going into a flight path that is on the other side of the world, seen from the Russian territory, so that we don't have telemetry only shortly before we have separation.
Now we're seeing all of the different stages coming off there. Can you tell us why it doesn't all happen in one go? Why is it happening in stages like we've seen?
Well, that is a way to optimize the efficiency of a rocket. So a rocket mainly consists of fuel that is needed to accelerate the payload, and you need a bit of a structure to put fuel into, and you need an engine. But once you actually have burn down all the fuel, then you can get rid of the heavy structure, and you go over to a smaller rocket which is then fired again. So at this point we are flying the second stage, which will be fired for about 3 minutes, and then it will be separated as well, and then only the breeze upper stage is continuing the flight and is putting the spacecraft into orbit.
So what happens when the breeze upper stage comes away? Can you talk us through that?
Well, it actually continues what the first two stages have done so far as well. It will enter into a 10 minutes acceleration phase as well. It will disappear into a zone where there's no visibility, so we will not receive telemetry at that point. We will see the first part of that flight, and it will actually bring the spacecraft into orbital flight. That means it will accelerate the composite to such high speeds that it's not falling back to Earth again. I mean, the first two stages, they're good to accelerate a bit and to climb altitude-wise, but they all fall back on the Earth's surface, and that needs to be that's what the breeze upper stage is good for, to give the last push to space to bring the spacecraft into orbit.
And what are we seeing here with this graph before?
This graph that is on right now, and which is, well, that is basically showing the flight path, and it gives you an illustration. I'm not sure if you can see. You see these trajectories plotted on the world map. You see we're starting from Plesetsk, we're going north towards the pole. We travel above Greenland, and then we come down over the North American continent, Pacific, and about 1.5 hour, 1 hour, 20 minutes later, we will come up again over the equator, and that is the point where we'll expect a separation of the spacecraft.
Well, I've just heard as well that we're now in the first burn of the breeze, so that's good news. Everything seems on track, and we've entered into the cruising phase now. So at this point, I'd like to thank you very much for talking through everything with us, Matthias Muck. Thank you very much.
Thank you.
Now, just a second, I'd quickly like to go over to ESA's Director of Observations, Volker Liebig. Just stay where you are, but tell us, are you pleased with the launch?
Well, I don't know whether you still hear my heart beating with the microphone so close. I'm still excited, as I'm always with launches. Everything so far is fine, yes, so I'm pleased. But we have still 1 hour 25 to go until we have the signal acquisition, and this is when I start to relax a bit.
Yes, of course. And don't worry, we will, of course, be keeping everybody up to date over the next hour. Thank you very much. And while Sentinel-3 is on its way into space, let's talk about some of the practical and useful things that will come out of the mission. Before that, though, let's have another little quick look at the beauty of the oceans from the film by Jacques Perrin, Oceans. Just a snapshot, really, of many of the creatures that live in the ocean that show us how fascinating they all really are. As you can see now, I've got a number of people joining me on the stage, and these are a few key people who are going to discuss and use the Copernicus data every day. We want to discuss how it's going to be helpful for them in their daily work. So let me please welcome Susanna Mecklenburg, first of all, ESA's Sentinel-3 mission manager. We also have Estelle Obligé, the Deputy Director of Space Oceanography Division at CLS in France. Hilary Wilson is with us too, Sentinel-3's Project Manager at EUMETSAT. Pierre-Yves Letraun, Scientific Director at Mercator Ocean. Andreas Brink, Senior Scientist at the Land Resource Unit of the European Commission's Joint Research Centre in Italy. We also have Vincent-Henri Puch, Head of the Copernicus Atmosphere Monitoring Service at the European Centre for Medium Range Weather Forecast. And then Thilo Erbertseder, Atmospheric Scientist at the German Aerospace Centre in Oberpfaffenhofen. Welcome to all of you. Now let's start with Pierre-Yves. The EU has defined 6 main thematic areas which it wants to address with the Copernicus program. I'm sure many of you know them. We have the emergency response, security, atmosphere monitoring, climate change as well, and land monitoring services. Mercator is tasked to provide the 6th, which is the Copernicus Marine Environment Monitoring Service. This is regarded to be the basis of ocean management. Pierre-Yves, what does ocean management mean exactly?
Well, let me first recall how important it is to observe the ocean. I mean, the ocean provides essential services to the society. They regulate climate change, they provide food, energy, and there are also many economic activities depend on our ocean. But our oceans are a threat because of climate change effect, but also to human activities. So they need to be better monitored
for better management and for the development of the blue economy. So the Copernicus Marine Service, which is indeed one of the 6 Copernicus service, was developed with these ideas in mind. So we are providing monitoring of the ocean, the global ocean, on the European regional seas for improving the management of our ocean and seas. And this is done by Mercator Ocean, and also with a strong European partnership. So we have more than 50 marine centers in Europe that are providing this integrated monitoring of the sea. So we describe the present state of the ocean, the past state, and also we provide a short-term forecast of the ocean.
So will Sentinel-3 give you better and more advanced data, and how will you actually feed that data into your system?
Yes, so Sentinel-3 will indeed provide essential data sets for our system. So we'll use the Sentinel-3 data and we'll ingest the data in our modeling and data simulation system to provide better products and better services for a wide range of applications.
Thank you very much. Estelle, CLS is working on some of the basic data that goes into the service. Can you tell us a bit more about that?
Yes, so CLS is a subsidiary of the French Space Agency. We're a team of remote sensing and ocean scientists, and we work to better observe, understand, but also protect our environment. We have many clients all over the world, and we help them making better decisions by providing intelligence and services based on Earth observation data from space, such as the one that Sentinel-3 will send us. I can talk about three examples of applications developed by CLS. The first one is related to the climate application. With the Sentinel-3 mission, we will have access to more data, more accurate, over new areas. And with our colleagues from CNES and Lagos, we will be able to better characterize the sea level rise, of course in terms of global trend, but also in terms of geographical and temporal variability. And these results will then be used by climate experts to predict the climate change impact. The second one is related to the iceberg detection. We will use the Copernicus constellation, SAR data from Sentinel-1 and Altimetre data from Sentinel-3, together with the forecast current provided by the Mercator Ocean model to predict the position of the iceberg and also to predict their drift. And this is a valuable information for the skippers or for the boat racing organization, for example. And finally, the last point concerns the marine resources. This is very important to put in place a sustainable management of the marine resources. And at CLS, we help both the governments but also the fishermen. For the governments, we feed our population model with remote sensing data, such as the one that Sentinel-3 will provide. And this population model provides a distribution of a given population of fishes in terms of maturity stages. And this is very important for the government in order to put in place better control and regulation. And in parallel, we also help the fishermen by providing them in real time weather and sea state conditions so that they are safer at sea and also they use less petrol, so they decrease their carbon footprint.
Well, ocean monitoring is just one part, of course, of the Sentinel-3 mission, but land observation and land monitoring is another one. Susanna, the data used for land monitoring is provided by ESA. Can you explain ESA's responsibilities with that?
Yes, as you've just seen, we had a launch, so ESA has been the agency developing the Sentinel-3A mission, and will be responsible to develop the sequels of it. And in the first 5 months of the time in space, we will have a so-called commissioning phase, which means that we are testing the functionalities of the platform and the instruments. And only when we are happy with that one, we will pass it over to the agency with whom we collaborate in the operations phase, to EUMETSAT, as we've heard already several times this evening. And that will be the split somehow. So EUMETSAT will continue to operate the platform and the instruments. ESA will continue to monitor the actual health of the satellites. So basically look at trends in the subsystems, etc., to make sure that we monitor very well the the health of the long time period of the mission. And then, of course, the great split between us is in between marine and land. So we will produce together up to level 1 data products, we call it. So that's really instrument data products. And then on top of this one, the geophysical data products, so-called level 2 products, will be split between land for ESA and marine for EUMETSAT.
Okay, great. And of course this data is free for everybody to use, and startups are starting to use it to develop their own businesses as well. But one of the main services making use of this data was actually established by the European Commission itself, and this also provides information to another of the main services called the Copernicus Land Service. So Andreas Brink, this brings us on to you. You're a senior scientist at the Joint Research Centre that works on behalf of the European Commission, and you work a lot with data. So how will you use the Sentinel-3 data?
Yes, indeed, we are responsible to manage the global part of the land service, and indeed, at the same time we have the lift-off here, we have the kick-off meeting of the global land service in Vienna, so this is a nice coincidence. We will be using this data for global assessments, for looking at global vegetation dynamics, global land cover, inland water, body dynamics, fire dynamics, at the global scale, but also at specific ecoregions or specific continents such as Africa. You know, not all the people are aware of the fact that the European Union is actually the biggest aid donor worldwide. So we provide more than 50% of the official aid globally. Some of this funding goes to, for example, the sustainable management of biodiversity in protected areas, because these are heavily under stress. At the JRC, we are looking at, you know, the health, the status of protected areas with this type of data. We look at the evolution of the dynamics of the vegetation over time in the protected areas and in the surroundings. This is critical information for the park authorities, because like this they can predict and follow, for example, the wildlife migrations. We all have seen the big migrations of the herbivores in the Serengeti, Masai Mara, for example. They follow the evolution of the vegetation, actually. Another big topic in the protected areas is the fire dynamics. And here we look especially at fires with reference to poaching. You know, in the last 3 years, about 100,000 of elephants have been killed in Africa, and sometimes rangers get killed too. So how can we use Sentinel-3 to you know, support this, stopping this killing? It's actually by the fire sensor, and the Sentinel-3 will really provide us improved sensitivity on small fires, even on lower sensitivity and intensity fires. So we will provide in near real time this data to the park managers, and they can then take action on the ground on this.
And what about the deserts as well? Does it help monitor those?
Desertification, land degradation is a difficult topic. We need, of course, this type of data. We need long-term monitoring to detect land degradation. There's not one single answer, not one single indicator. We need to bring together different evidences from Sentinel-3, from Sentinel-2 also, and from field data to monitor land degradation.
Okay, thank you very much. If we go now to Vincent-Henri Puch. Now, of course, the ECMWF is known for weather forecasts, but it also works to achieve goals set by the European Union for two of the Copernicus pillar services, those of the atmosphere and of the climate monitoring, of course. So what advantages will you see with your work with the data from Sentinel-3?
Well, actually, at ECMWF, we have 3 reasons to be very happy tonight with Sentinel-3. You've mentioned these 3 reasons. I will elaborate a little bit. For the atmosphere monitoring service, which is one we manage, we expect a lot from Sentinel-3 in the area of aerosols, particulate matter in suspension in the atmosphere. Aerosols are very important for climate, as you know. They are very important also for air quality, and Thilo Herbetseder will elaborate on that. But also we are very much interested in fires, like the colleague. Fires emit lots of material in the atmosphere, CO2 in particular. So it's essential essential ingredient of knowing what are the forcings on the climate systems. Second reason to be happy is the climate service. So with 2 decades of Sentinel-3, we will build over the years consistent climate data records about the surfaces, ocean, land, ice sheets, glaciers, etc. So that will underpin the Copernicus climate change service. So it's really important for Europe, but also for the world and in the follow-up of COP21. And third reason why we are excited is our core business, numerical weather prediction. The Sentinel-3 will bring to a suite of satellites that we use on a daily basis. We know now that atmosphere and ocean are not just two separated entities, that interactions are very important, and with products like waves, it's not only helping us predict better with the weather, but it's also improving the weather itself. So 3 reasons to be excited, and I will add a 4th reason. It's an operational mission, which means that we have a guarantee of service which is essential for us.
Well, just going back to the weather, you mentioned obviously that the satellites benefit weather prediction. Does that make any difference between short-term and long-term weather predictions?
Yes, the observations are especially important for long-term or medium-range to long-term weather forecasts. So it has taken some decades actually to harness the full potential of satellite observation to improve medium-range weather forecast. We know today that satellites amount approximately 2 to 3 days of skill. That is a weather forecast which is initiated with satellite data is good. The skill at 5 days is equivalent to a weather forecast which is initialized without satellite data at 3 days. So there are massive societal value, which is thanks to satellites. And with Sentinel-3 in particular, again, the wave height, we expect to have benefits in forecasting wave heights of the order of 9%. We will improve also the forecast of weather in general in winter. And last but not least, with surface altimetry, we expect to improve seasonal forecast. That is forecasts from 1 month ahead to 7 months ahead, especially in the tropical Pacific. So again, lots of societal value in store.
Okay, well, of course, providing the data to predict the weather is what EUMETSAT do, so that brings us nicely on to you, Hilary. And of course, you know, as we've heard a lot this evening, EUMETSAT are helping with this satellite, and just short of 18 months from now, Sentinel-3B will be going up and being ready to fly as well. Are you prepared for that one?
Yes, we are, of course. One of the important things about the Sentinel-3 mission is that it's a tandem mission, which means that we are having to fly 2 satellites in parallel to achieve the on-ground coverage within a few days. Sentinel-3B launch and preparations is really the first opportunity to do something that we will be doing for the long term, which is continuously evolving the ground segment. The satellite is staying broadly the same. We're not going up in orbit to fix it in any way. But we will do it from the ground. We will evolve our ground segment. Sometimes these evolutions are very small. We're fixing a bug in the software. Sometimes they are larger. We are improving an algorithm to derive a better product for the users. Or sometimes they're really quite large, where we are actually replacing all of the hardware that we are using because that's becoming obsolete. And what we do is continually improve our ground segment so that we have this long-term view, which everyone understands is really important for both meteorology as well as oceanography. A long-term view. We do not like surprises in operations. We like slow, steady improvement to the product quality. We are very much looking forward in our 30th birthday year to welcome Sentinel-3 to our big stable of operational satellites.
Well, of course, the data quality is a very key issue for Sentinel-3. Susanna, maybe we can come back to you just quickly. Who's defined the instrument on board Sentinel-3 and the way that it will be used?
Yes, the original definition of the instruments that were put on Sentinel-3 is of course based on the requirements that we had from the users and from their experience of previous data sets that we had. In particular here of ENVISAT and CryoSat. These are instruments that have been flown before. People have experience with these data. They can build their applications and their scientific research on the basis of this. And that's the spirit of the Sentinel missions in general, to provide continuity to something that we had before, to for applications, everyday applications, but also for climate research. So that's the idea. And the way that came about was a consultation process that the European Commission ran about 10 years ago or even more, meanwhile, where then eventually it was decided what instrument was going to be put on what platform in the whole suite of the 6 Sentinels.
Okay, thank you very much. We'll come to you, Thilo. We haven't forgotten you at the end there. You're working on the DLR, German Aerospace Center, remote sensing data unit. And of course, you use satellite data to monitor aerosols and their impact on our personal health. This is something that's really interesting for me, actually. How do satellites help us stay healthier?
Yeah, I mean, satellites like Sentinel-3 indeed contribute to make our lives healthier and to increase the quality of life. Sentinel-3 got 2 instruments with ALGI and SLSTR that can monitor the aerosol burden and the aerosol distribution in synergy. And the aerosols have a strong impact on our health. So this is best documented by the fact that the aerosols in the air, the particulate pollution, reduces the life expectancy in Europe on average by 8 months. So this is a very strong impact. And also there are epidemiological studies from the World Health Organization that particulate pollution causes worldwide about 7 million premature deaths. So this outnumbers the death toll of malaria, for example. And instruments like Sentinel-3 give us the unique capability of global monitoring of the aerosol variability, the transport, the tracking of aerosol plumes, and also to look if the policies in place are working and are successful. And
so where does this aerosols come from, and what can we do to cope with the problem?
There are different sources for aerosols. These are the natural sources, like desert outbreaks or mineral dust transport towards Europe or the US. So although this is a bit linked to desertification and climate change, as was pointed out here, but this is more natural origin. But then are the anthropogenic factors, that is the aerosols from combustion processes, from heating, wood burning. Also in the cities it's a big problem. Also the local emissions, and also from agriculture. So here we can really look if the policies in place are working and are successful, and satellite data can be used complementary to the in situ measurement networks that are in place for regulatory purposes. And another big thing is the preventive medicine, that the aerosol data from the satellites are combined with the air quality forecasting schemes that are run at the ECMWF, at the Copernicus Atmospheric Monitoring Service that is headed by Vincent Ripper. And we take this data and build downstream services upon that data, and we have been demonstrating this in several Copernicus projects, that we use satellite data in combination with the air quality forecasts in providing dedicated and targeted information on upcoming pollution events for people at risk, people suffering from asthma, pulmonary diseases or cardiovascular diseases, so that they are informed in advance to take the precautionary measures, their relief medication in advance. And this is also a big impact on our health system, which is currently about 27 billion euros per year, and the preventive medicine.
I heard you mentioned once before, actually, about the fine dust pollution, and just a fact for you all, 10% of the fine dust pollution from the year actually comes from our New Year's Eve fireworks that we have every year, which is a fantastic percentage, and what an amazing impact on our health. I'm going to have to leave it there. Thank you very much to all of you for your contributions there this evening. Now I do believe that, thank you. Now, ladies and gentlemen, we are half an hour into the flight of Sentinel-3. So before we go for a short break, let's go back over to Plesetsk. Guido Levrini is there for us again. Can you give us an update on the flight, Guido?
Yes, Louise, everything went perfect. At the moment, we don't have visibility of the upper composite of BREEZE with the satellite. So we don't have real-time information. We are blind, so to say. This will last for a little more than 1 hour. BREEZE with the satellite went over North Canada, the west coast of the United States, over the Pacific. We go over the South Pole, we re-emerge over Madagascar, and we'll be over Madagascar at the right altitude by the time we will reconvene after our break. But we have to wait a little bit more to get the real-time information. What I can say is that until now, everything went according to plans.
Well, that is fantastic news. Thank you very much for filling us in. Now, before we continue our program here in Darmstadt, as we've heard, it's time to take a break. When we return, we'll hopefully hear the news on the separation of the satellite from the rocket, and it's at that point that the mission of Sentinel-3 will truly begin. If you want to talk to some of our experts in the break, then please feel free to approach our ESA communication staff here on site. And if you are watching us via your TVs or computers, then please get in touch via Twitter using the hashtag Sentinel3. We'll be back at 8:10 Central European time, so stay tuned, and I'm going to leave you with a repeat of the launch of Sentinel-3. See you shortly.